Okay, so this is called handling data. They start out with talking about variables. We know about variables. Declaring variables. They introduce another form which I don't think we've talked about, called decimal. So you can declare a variable as a decimal. However, he says that actually you'll get an error here. If you treat these statements if you put these in a button click, the compiler may underline the statement that assigns value 0.35 to the discount variable and generate an error message. To view the error message, however, hover the pointer over the underlined segment. So you put it over there. This will happen if strict option is on. By default, the strict option is on. Is off, sorry. And it won't generate an error. The compiler treats any numeric value with a fractional part as a double value, and detects that you're attempting to assign a double value to a decimal variable. To specify that a numeric variable should be treated as a decimal type, use the following notation here. To put a D after it. Alright, but we are not going to worry too much about that, but okay, so we know about declaring variables. Here are some examples. We know about initializing a variable, means giving it a value. We know that there are numeric variables, string variables, Boolean variables, date, and object. We haven't talked about object. Object variables can store any type of data. So they can store any of the other ones. Why bother to specify the type if one type suits all? On the surface, using object variables might seem like a good idea, but they have their disadvantages. Integer variables are optimized for storing integers, and date variables are optimized for storing dates. Before VB can use an object variable, it must determine its type and perform the necessary conversions. If the variable is declared with a specific type, these conversions are not necessary. So remember that conversions take time. So we don't generally declare something as an object variable. So here he's talking about single and double precision numbers. Now in general, if you divide 1 by 3, of course the answer is this, and it doesn't end, right? But of course a computer can't not have something end. So now he tries to give us an example of the difference between single and double. So suppose we declare A as a single and B as a double. And then if we remember A is a single, if we assign this value to A, and then we debug right line A. Now here he's starting to use this debug stuff that we talked about earlier in this lesson. So you can use this also, or you could write it to a message box. He said if you run the application, you should get the following in the output window. Maybe that's why I didn't see it. Maybe it's supposed to show up in the output window. Maybe if you leave it unchecked, like I told you to check it, but if you leave it unchecked, maybe it will show up in the output window. Okay, so maybe that's what you should do. Uncheck that option that we checked, and then check it, see if this shows up in the output window instead of in the intermediate window. So anyway, if you do that, you're going to get this answer. So this is what this is equal to if A is a single. Now if you multiply A by, what is this, 100,000, and then write that, then you're going to get this number. Okay? So it was equal to what? How many 3's are there here? 7 3's, right? Yeah. But here we have 6 3's and a 4. So it's not actually the same. I'm sorry, it's not what you would have expected. You would expect this to be a 3. And the result is not as accurate as you might have expected initially. It isn't even rounded properly, right? Because this shouldn't be rounded to 4. Actually, it would be rounded to 2. Sorry, rounded to 3. if you divide A, now if you take this and divide by 100,000, you get this now. So you don't even get the same thing that you started with. So you multiply by 100,000, and then divide by 100,000, and then you don't get the same thing back. This number is different from the number we started with. The initial value was rounded when we multiplied by 100,000 and stored in a single variable. This is an important point in numeric calculations, and it's called error propagation. So the error we got an error basically when we multiplied by 100,000, and then the error continued when we divided again by 100,000, or divided it by 100,000. And that's called error propagation. In long sequences of numeric calculations, errors propagate. Even propagate means to sort of continue, right? Or spread. Even if you can tolerate the error introduced by the single data type in a single operation, the cumulative errors might end up being significant. So you might get more and more errors and as you perform more and more operations. Let's perform the same operations with the double precision numbers, this time using the variable b. So again, we start with 1/3. So this time b is equal to 1/3. Write that, then multiply by 100,000, and then write that. So then we get, so this is what we get when we write 1/3 now. It has more precision, and this is what we get when we multiply by 100,000. So we don't get that error. The results produced by the double precision variables are more accurate. Why are such errors introduced into our calculations? The reason is that computers store numbers internally with 2 digits, 0 and 1. So we know that, right? We said that everything is represented by zeros and 1. This is very convenient for computers because electronics understand 2 states off and on, right? You have a circuit, and it can be either on or off. As a matter of fact, okay, so we know about that. Another example, he says, create a single precision variable a and a double precision b, like this. Here's a, here's b. Then print their difference. Okay, that's also going to be interesting. Write their difference. If you execute these lines, the result won't be 0. It will be this number. And remember, this is a very small number because this is we're taking this number here and multiplying it by 10 to the negative 10. This means multiply by 10 to the negative 10. So if you take this number and multiply it by 10 to the negative 10, you get this. Okay, but it's not 0. Because different numeric types are stored differently in memory, they don't quite match. What this means to you is that all variables in calculations should be of the same type. Okay, because you don't want to have different types of variables in one set of calculations. You might end up somehow like something like this. He says, eventually computers will understand mathematical notation. They'll know what we mean by 1/3, but not yet. So 1/3 now is stored as a decimal. Okay, as another example, if this is equal to 3 and this is and these are singles, I'm sorry, if these are singles or doubles, if we have 3 and 1 over a here, and we multiply a times b, you'll get 1. Okay, if the two variables are declared as decimals, however, the result will be very close to 1. It'll be this, but not exactly 1. There will be 28 digits after the decimal. Fortunately, these errors do not surface with typical business line applications, so this doesn't really happen when you're doing business. This is called a truncation error, and it might be more important if you're doing scientific calculations. So I'm going to let you do a little research on your own, if you like, about the decimal data type. We don't have time to go over it, but you can do a little research on it. Okay, you can read this about type characters. And he says there's a table here about type characters. Here's the one we use, D. Converts it to decimal. And there are these other ones as well. You can read this. Okay, also infinity, we didn't really talk about it, but an NaN, not a number. These are special values. NaN is not new, but an example of where it might occur is the log function. You might remember that the log function cannot accept, you can't put in a negative number in here, if you might remember that. So if someone puts in a negative number in here and tries to assign that to a variable, the result will be that variable will be equal to NaN, not a number. And then if you multiply that by something else, that's also going to be NaN. Okay, so this NaN will continue to, it'll just stay there. If there's an NaN anywhere in a calculation, the whole thing will be NaN. And there's also something called infinity. That's another possible value. So if you have, let's see, double as this one as a double 999, then divide this by 0, and then display the result in a message box, this is what you'll see in the message box. Remember, a message box converts sort of a value to a string, and so this is the string that you get. Alright, we don't really have time to deal with infinity very much either. He does say you can test, you might want to have a test, so only run something if it's not not infinity and if it's not NaN. And you can use these methods. Is NaN is a method, and is infinity is another method of the single and double data types. For example, so we have variable 1 and variable 2 is are two doubles, and then we have the double, and then we can use this is infinity and apply it to our variable. Our variable is here. So if it is infinity, then give something, and otherwise they check, is it not is it NaN, and so on. So you can use this double is NaN, and double is infinity, and there's also more. There's double is positive infinity, and there's a negative infinity. Didn't use it, but you can use all of these. Okay, a little bit more in byte variables. None of the previous numeric types is stored in a single byte. Remember, a byte is 8 bits, and those variables are not stored in a single byte. They're larger than that. In some situations, however, data are stored as bytes, and you must be able to access individual bytes. The byte data type holds an integer in the range of 0 to 255. Bytes are frequently used to access binary files, like images and sound files. To declare a variable as a byte, you use this. The variable n can be used in numeric calculations too, but you must be careful not to assign the result to another byte variable if its value might exceed the byte type. So here's a kind of weird thing that you get. Suppose A and B are both bytes, and you have A and B like this, and you write that. So it's the result can't, I'm sorry, it's not so weird, but the result can't be stored in a single byte. So don't he says don't do this, basically. Visual Basic generates the correct answer, but it can't, I'm sorry, you can do this. It'll give you the right answer, but don't try and assign this to another byte variable, because you can't store it in such another byte variable. He says that it will produce an overflow exception. Overflow means there's not enough space to store that. Now here's something we don't have time to go over, but you might try and look it up. Suppose you have 2 bytes, one with this value and one with this, and you use the so-called AND operator on them, the Boolean operators used with these byte variables. You'll get this weird result. So this and this give you this, and the reason is if you express this one in its binary form, it's this, and if you express this one in its binary form, it's this. And then the AND, we don't have time to do it, but it takes this variable, this value and this value and does AND with it. What I mean that is 1 and 0. Those are not the same, so it gives you a 0 in the result. And then the next one is 1 and 0 again. It gives you a 0 in the result. And it keeps going. So this one is, I think, 1 and 1. Those are the same. So it gives you a 1 as the result. Anyway, I don't know if that's clear or not, but you can look this up somewhere. Okay, one more that we didn't spend much time on is character variables. So character variables allow you to you can only put one character in a character variable. So like, just the letter A or just the letter B or something like that. So you can declare character variable like this. And one other thing, character variables store a single Unicode character, and they require 2 bytes, not 2 bits, 2 bytes. So 16 bits, right? So they are basically the same as an unsigned short integer, take up the same space. So you can declare 2 character variables, this one and this one, as character like this. And you can initialize them like this. So this one is equal to this, and this one is supposedly equal to this, but it doesn't really, this doesn't exactly work. So if you try to write these, you will get an error, and it will only work if the strict option is off. We talked a little bit about the strict option. I'm going to talk a little bit more about it later in a few more minutes. If the strict option is on, these will be marked as errors. So when this will be marked as error. Okay? So you have to use these, what are they called? You have to use this, C, to say this is a character variable. Otherwise it's trying to interpret this as a string. But it's not supposed to be a string, it's supposed to be a character. So if you put this here, then it says no, force it to be a character. And force this to be a character. Now this doesn't say ABC anymore. Okay, just A. It's just supposed to be a single character. Now if you have strict off, then it would have worked, and they both would be A. This one would be little a, even though we did this here. It would only take the first character, so it would only be A if strict was off. Now, if you want to know what the code is for A, you can do this. You can do this. Convert to int 32A, and the code will be 65. That's the ANSI code, not the Unicode code. And if you want to know what the character alpha is, you can put alpha in here, and you'll get this number. This is not ANSI though, because ANSI only goes up to 256. This is the Unicode value, and Unicode for pi is this. For English characters, ANSI and Unicode match, but Unicode has much more space to store many more characters. So after 256 characters, Unicode will have its own set of values. And all, like Japanese kanji and Chinese characters and Sanskrit, Hindi, Thai, and Korean, they all have, all the letters, or whatever they're called, all have their own unique Unicode value. So here's a little example of using when you might use characters. So he says character variables are used in conjunction with strings. You'll rarely save real data as characters. However, you might have to process the individual characters in a string one at a time. Let's say the string variable password. So we have a variable called password, and it holds a user's new password. And you require that the passwords contain at least one special symbol. So you might have this code here, which will scan the word password, or scan the variable password, and reject it if it only contains letters and digits. So it has to have something other than letters or digits, and you need to check. So we define the string variable password and ch as a character variable, and I as an integer, and valid as a boolean, and initialize it to false. So while not valid, so we're going to have a while loop here, and now boolean is valid is set to false, so it's so not valid will be true. So at least at the beginning, this will run. This loop will run, but maybe we'll change boolean to true. Valid to true later, and then it might stop running. The loop might not go iterate again. Anyway, so password, we're setting password using the input box. Please enter your password. So the user will enter their password, and it will be stored in here. And then we have a loop, another loop. This is a loop, and here's a loop inside that. So for I equal to 0 to what? Password dot length minus 1. So not going through the so if the password length was 5, then we'd be doing this 5 times, because it would be 0 to 4. That's 5 times. Now set ch equal to password.char. Now here again, we're going to explain this in more detail in a little while, but password, of course, it's a variable, right? It's just, we declared it up here as a variable, but it's also an object, and we can call methods based on it. And one of the methods for this string type of variable, or string type of object, is this method, and it gives you the character of whatever index you have here. So if this is 0, it's the first index. It's the first character in the word password. If this is 1, it's the second, and so on. Remember, we start from 0, not from 1. Okay, so if not Okay, so here we're taking the so what we want to do is we want to check whether this, which is our first character at first, we want to check, is it a letter or a digit? And we call that function, we have to start it, this function is an object, is a method of this object. So we have to call it like this, just like when you did you did array.sort in the last week's homework. You had to say array dot then the sort function. Here you have to say car dot this function. Okay, so now we're checking to see whether the first one, because this is the first one, because I is 0, so it's the first character in the password, and we're checking to see is it a letter or a digit, and if it's not, then valid equals true. So we found a non-letter digit character, so then that's what we wanted to find. So if we find it, then we can so if we find it, then we will exit the for loop. We don't need to go through all the other letters then. Otherwise, this doesn't get set to true and we don't exit the for loop, and we keep going. Finally, we go through all of the characters, and if valid does get set to be true, then here's the, where is it? End while. So if valid gets set to be true, we don't repeat this, but if valid is not true, let me get this. Sorry, here. If valid, that means if valid is true, then give this message. Otherwise, give this message. Something seems a little bit wrong. No, this is right. What I was confused about is that if valid is not true, that is, if we haven't found one of these special digits, if we haven't found that, then we're going to keep going through this loop again, the outer loop. And the outer loop will just generate a new password box for them to enter their password. So it'll just keep doing that until they finally do the right kind of password. Okay, so this is an example of using characters. Okay, date variables, I'm not going to go through it, although they're very important. He says one thing, now and today. We've talked about now. By the way, the today function returns the current date and time, while the now function returns the current date. So you can have, it would seem like it's just the opposite, but maybe that's right. You can retrieve the current date by calling the today property of the data type date.today. Okay. So you can get the current day date rather by doing this. Okay. So I'm not going to go through this date stuff. Okay, the strict, explicit, and infer options. So the explicit option indicates whether you will declare all variables. So if you have, so the default I think is the explicit is on, but you can set it to off. So you should leave it on though, because you should always force yourself to declare all the variables. Otherwise you might end up with wrong results that the compiler won't catch. Now the way that you turn it off though is you go to the very, very top of your code. It can't be inside anything. So it has to be even above here. Even above there. It has to be up here. So if you have that on, then you see here I here's a variable xxx, and I didn't do a dim statement for it, but I'm still using it, and the compiler isn't complaining. And that's not really good. If I get rid of this, and now I'll click somewhere else, now it complains, right? So it's not a good idea to do this. Okay? The strict option indicates whether all variables will be of a specific type. So you have to, if you declare a variable of a certain type, you can only use it when it's of that type. So if you turn that off, you'll get conversions from one type to another. So you'll start with something which is a number, and you set that number equal to a string. It might automatically become a string. Let's see if that works. Well, I didn't actually try it, but let's see. They say another option, related option, is the strict option. That's what I was just talking about, which is off by default. The strict option tells the compiler whether the variable should be strictly typed. Strictly typed or strongly typed variable must be declared with a specific type and can accept values of the same type only. So that's off by default. With the strict option set to off, you can use a string variable that holds a number in a numeric calculation. So here it's a string, but you can do this a divided by 2 and it won't complain. Remember, this will write to the immediate window. Likewise, you can use numeric variables in string calculations. So you can do double and add 1, add a string, and it will still work apparently. Okay? And you need to put that also, if you want to turn that on, strict on, you need to put that at the very top. Okay, you can check more about these options. Okay, we said object variables can take any kind of data type. These used to be called variants in version 6, Visual Basic version 6. Now they're called object variables. So and you can set strict off, and then you can just do this, and it will be treated, it will assume that you meant object variable. In other words, just yeah. And or you can, with strict on, you have to say this variable as object. Then you can assign anything to this variable, but again, it's not the way we should program. But you should understand what we mean by an object variable, or an object data type, I'm sorry. Okay, now the next topic is very interesting, and we'll come to this in the next video.